All right, so I really like this worksheet a lot. It's this integrated 2525 part 2 worksheet, and it's essentially word problems, and it gives you the opportunity to sort of see what parabolas do. I'll tell you, if you look at these equations, they're kind of a mess, so I strongly encourage you to use a calculator on this worksheet. So I'll do a couple of these problems and leave the rest to you. So it says a square and a rectangle have the same area. The length of the rectangle is 5 inches more than twice the length of the square. So this is kind of like what's going on here. So we have a square and we have a rectangle, and they have the same area. It says the length of the rectangle is 5 inches more than twice the length of the side of the square. So let's call the side of the square x, and let's call this 2x minus 5, right? Oh, wait, 2x plus 5. So it says the length of the rectangle is 5 inches more than twice the length of the square. The width is 6 inches less than the length of the side of a square. So these are going to be equal to each other, right? So I'll just say, oh look, x times x is x squared is going to be equal to, maybe I should put this in an area model, right? Might be easier to write it like this, if you guys are following me. So I'll make this x minus 6 right here. I get 2x squared minus 12x. Here I get 5x minus 30. So I'm going to say x squared equals 2x squared minus 7x minus 30. I'll subtract x squared from both sides. So I'm going to get x squared minus 7x minus 30. I'll try this on the diamond. I'm going to get negative 30 and negative 7. So I get x and x on the side. And it looks like 1 and 30 isn't going to give me 7, 2 and 15 isn't, but 3 and 10 might if the 10 is negative and then the 3 is positive. So something super interesting happens real quick right here. So I get x minus 10 and x plus 3. Well, think about my solutions are 10 and negative 3. Well, how could this equal negative 3? It couldn't. That would be super weird if it was, right? Like a negative 3 and a negative 3 length. So this is a real solution, but it doesn't make any sense. The 10 is the only one that makes any sense. So if this is 10 and this is 10, I'm going to get an area of 100. Over here, 10 minus 6 is 4. And over here, 2x plus 5 is 25. And guess what 4 times 25 is? It's 100 as well. So that kind of works. So it's kind of interesting what you can do with this type of math. Now, we're just scratching the surface. I just want to show you what it is. I don't really expect you to be able to do this necessarily, although I would love for you to try in problem number 2. It's very similar to problem number 1 in that regard. All right, so let's just randomly pick here. It says Abigail, who has a bionic arm, is crossing a bridge over a small gorge and decides to toss a coin into the stream for good luck. The distance of the coin above the water can be modeled by the function y equals negative, make sure you catch that, negative x 16 x squared plus 96 plus x plus 112, where x is the time in seconds and y is the height in feet above the water. So it says find the greatest height the coin reaches before it drops into the water below, and find the time where it hits the water. So I'm going to go ahead and I'm going to show you how to do this in this calculator, although I think most of you will probably use Desmos. I still think it's important to know how to use these calculators. So I'm going to put y equals, and what that's going to do is I will put negative 16x, where's the x at? There's the x. I could just put the squared here, right? But don't forget I can use the caret key if I wanted to. Plus 96x plus 112. And I will graph that. And you can see that's what the graph looks like. It doesn't look great. So I'm going to go zoom stat. Actually, I don't think this is going to work. Zoom 9 is zoom stat, but I don't think that's going to do what I wanted to. Yeah, it didn't. Okay, so instead I will zoom out so I can get a feel here. And a couple things going on here. again, this is not really looking that fabulous. So zoom out again. I think I'm getting into Desmos being a way easier territory. So you can see this is all sort of screwed up here. But what if I go ahead and I change my window to a -5 and an x of, I don't know, +5. Oh, that's right, I keep hitting the negative key instead of the minus key. Here I'll go +5, and I will change my scale from like -5 here to like 175. Now let's see what that looks like on the graph. Does that look any better? Yeah, you can see I sort of missed there. So I'm going to go to the window again. I'm going to change this maximum to like 20. I'm just changing the window size, right? Not a huge deal, but trying to get at least, okay, now it actually appears here. So how do I go ahead and figure out where these things are at? And if you see this button right here, it's the trace button. What that allows me to do is it basically sticks the cursor on this thing, and as I move it, it will stay on it. So I don't know where my cursor is right now. Am I off already? Oh yeah, okay, I'm already off. So here I am coming back. You can see I'm looking at the Y's. I'm getting closer to 0, so there we go. Now I'm reappearing. So you can see it was really close at about 7 seconds. X is 7 when Y became 0. And the top of it, it looks like it's about 255 feet in the air, roughly. So not exactly, but about. Again, let me go ahead and set this up in Desmos so you can see it looks a lot clearer. So you can see it's just way easier to kind of manipulate this, and you can see there. Wait a minute, I think I have the wrong equation. Yeah, I want to put 96x plus 112, sorry. So 96x. There we go, so it's even further. So I will keep going there, but you can see it's way easier. So 3 seconds, 256 feet, and then down here, 7 seconds, it was at 0. So it's a lot easier to see using Desmos than it is using these graphing calculators. As a matter of fact, I'm sure I showed the kids in class the graphing calculators because that's what we're using, but I don't really see the point in going into great detail. You guys are going to use Desmos, but you see where it's in blue, it says table. If I put second graph, now it actually gives me my X's and Y's, and you can see there we have, 3 at 256 and 7 at 0. So I think the table probably looks a little bit better than manipulating the graph anyway. I don't know why I didn't think of that earlier, but finally, greatest height, 256 feet. And how many times it hits the water? Well, it hits the water over here at 7 seconds. So you guys can go ahead and use Desmos or a graphing calculator to solve the rest of these.